So good morning. In this class we are discussing about the analysis of first stage of Darlington amplifier circuit. Okay. So for this analysis of first stage. For analysis of first stage, we go for the exact model of hybrid parameters. So here the load resistance of first stage. So that is here the load resistance of first stage. The load resistance of first stage RE1 is equivalent to RI2. The load resistance of first stage is equal to input resistance of second stage. We already know the value of RI2, that is 1 plus HFE RE. Okay. So here RI2 is very high. It means that RE1 is very high. It does not meet the requirement RE into HOE less than or is equal to 0.1. So that's why we go for the exact model of analysis, exact model of H parameter model. First draw the CE configuration. Okay. So CE means emitter is common, input is given to the base terminal, output is taken at the collector. HIE, HRE, VCE, HFE, IB, HOE. So this is the collector. So this is common emitter configuration. For Darlington pair, we follow the common collector configuration. So the same circuit can be redrawn for CC. Common collector configuration. First draw the collector is common. Again here also input is given to the base. So base to output is taken at the emitter. So base to emitter HIE, HRE, VCE. Okay. Next emitter terminal is output. Emitter. So now the collector, the same circuit can be redrawn. So just ilaga wish cheyandi. Collector. HFE, IB, HOE. Okay. So here it is plus and minus. So collector is plus. So here collector plus, emitter minus, and this is VCE1. First stage input is V1 and it is connected with RE1. Okay. So this is IC1, IC1, IE1, and this is the IB2, second stage base current, IB2, output current IB2. So this is the circuit for common collector configuration. First, we have to find out the current gain. Current gain, that is AI1 is equal to output current by input current IB2 by output current IB2 by the input current is IB1. Okay. So output current by input current. So here IB2 is equivalent to IE1. So that is IE1 with opposite polarities. So minus. So AI1 is equal to IE1 by IB1. So here IC1 is equal to, from this circuit, IC1 from this circuit IC1 is equal to HFE IB plus HOE. సో ఇక్కడున్న వోల్టేజ్ డ్రాపే ఇక్కడ ఉంటుందండి VCE. సో HOE minus VCE 1 minus plus. So that is equal to HFE IB plus HOE. What is VCE 1? V is equal to I into RE1. So that is IE1. So that is VC1 is equal to IB2 into output current అనుకుందాం, IB2 into RE1. So that is minus kada HFE IB1 plus HOE. IB2 is equal to minus IE1. So minus into minus plus kada IE1 into RE1. Okay. So that is the first equation. Now at node C, here at node C, the equation is IB1 plus IC1 plus IE1 is equal to 0. Okay. So from this IE1 is equal to minus of IB1 minus of IC1. IB1 plus what is IC1? This is IC1. HFE IB1 plus HOE IE1 into RE1. Emitter voltage capital E, RE1. So that equal to minus IB1 minus HFE IB1 minus HOE IE1 into RE1. So from this IE1 plus HOE IE1 into RE1 is equal to minus of IB1 1 plus HFE. Okay. So IE1 is equal to 1 plus HOE RE1 by RE1 equal to minus IB1 into 1 plus HFE. So from this minus IE1 by IB1 is equal to, from this minus IE1 by IB1 is equal to 1 plus HFE by 1 plus HOE RE1. Okay. So RE1 is equivalent to RI2. So 1 plus HFE what is our RI2 is equal to 1 plus HFE by 1 plus HFE RE1. RE is equal to 1 plus HOE. Okay. So this is the equation. So AI1 is equal to 1 plus HFE by 1 plus HOE. Here HFE is far greater than when compared with 1. So it simply write as HFE into RE. So this is AI1. So current gain for first stage AI1 is equal to 1 plus HFE by 1 plus HOE HFE RE1. Okay. Next to find out the input resistance. So input resistance RI1, input resistance for first stage. RI1 is equal to, from this circuit by considering the KVL at the outer loop only. So V1 is equal to voltage drop here HIE into IB1 HRE VCE is equal plus VCE1. So only outer loop, KVL at the outer loop. The equation become V1 is equal to IB1 HIE plus HRE VCE minus VCE1. So minus means here negative polarity. So from this HRE VCE value is 2.5 into 10 to the power of minus 4. It's a very small value. It can be neglected. So then V1 is equal to IB1 into HIE minus VCE1 means, what is VCE1? I into R. So this is IB2 into RE1. Again minus IB2 into RE1. So then IB1 plus IB1 into HIE plus IB2 into RE1. Okay. So divide the equation with IB1. Then V1 by IB1 is equal to IB1 by HIE by IB1 plus IB2 by IB1 into RE1. So then it becomes V1 by IB1 is equal to RI1, V by R. RI1 is equal to HIE plus, what is IB2 by IB1? Here IB2 by IB1 is equal to AI1. So AI1 into RE1. So what is the equation for AI1? This is 1 plus HFE by 1 plus HOE HFE RE. So HIE plus 1 plus HFE into 1 plus HFE HOE into RE into RE1. Again HIE plus, what is RE1? RE1 is equivalent to RI2. The output resistance first stage is equivalent to input resistance of the second stage. Again, what is RI2? 1 plus HFE into RE. So 1 plus HFE, RA place lo RI2 value. 1 plus HFE into RE by 1 plus HFE HOE RE. Okay. So then equation become HIE plus 1 plus HFE whole square into RE by 1 plus HFE HOE RE. By comparing with these two terms, HIE can be neglected. So finally RI1 is equal to 1 plus HFE whole square into RE by 1 plus HFE. 1 plus HFE HOE into RE. So this is RI1, that is input resistance of the first stage. Okay, RI1 input resistance of the first stage. Next, we have to find out the overall current gain. Overall current gain. So in cascade connection, the overall current gain AI is equal to AI1 into AI2. So what is our AI1? So AI1 is 1 plus HFE by 1 plus HOE into HFE into RE. So AI1 is equal to 1 plus HFE by 1 plus HOE into HFE into RE. What is AI2? AI2 is 1 plus HFE into 1 plus HFE. So then 1 plus HFE whole square 1 plus HOE, HFE and RE. So this is the overall current gain of the Darlington transistor amplifier circuit. Okay. Next, overall voltage gain. So overall voltage gain generally for analysis anta cheste manaki final em ostudante AV is equal to 1 minus HIE by RI. Okay, so overall voltage gain means AV is equal to AV1 into AV2. So AV1 is equal to 1 plus HIE by RI1. So AV2 means 1 minus HIE by RI2. Okay, so by multiplying these two, 1 minus HIE by RI2 minus HIE by RI1 plus HIE square by RI1 into RI2. So this is the overall voltage gain of the overall voltage gain of the Darlington amplifier circuit. So AV is equal to 1 minus HIE by RI2, just multiplication. RI2 HIE by RI1, HI square by RI1 plus RI1 into RI2. Thank you.